Okay, in this video, next we have is number of periods when you have an annuity. So earlier we looked at number of periods when we only had one cash flow at the time 0 and then one cash flow at some time period t, but there was no regular payment. Here we have payment every period. So again, that's annuity. So in this example, let's say if you take, if you use your credit card and you put $10,000 bill on it, and then you will be making $20 payment every month for this card, and the interest rate is 1.5% per month. How long will it take? So you have bought something worth $1,000 using your credit card. So that's your positive, that you got something worth $1,000. So that's present value, positive, and you will be paying $20. So that's negative. The formula is same still. So NPER that we used before. And then start the parentheses. It is asking us what is the rate. So again, since we have monthly data here, so we need monthly rate, and since 1.5% is already given to you in monthly value, so that will be 0.015. Payment, we will be paying $20 every month, so that's negative 20. And then we have a present value of 1,000 because we have used credit card, so we have bought something worth $1,000, so that's a positive value. And then end the parentheses, enter. It will take us 93 months to pay it back, that credit card loan that we have. So just a reminder that you could do that as an input-output value like we saw in the first video. So here we have the input value of $1,000 as the present value, and then we have negative 20 as the payment, and then we have 1.5% as the interest rate. Okay, so then we could, instead of putting in the value in the formula, we could have referred to a cell value or cell number. So the rate is in cell A10, payment is in A9, present value is in A8, and then close the parentheses, enter, and you'll get the value 93. So in fact, when you work on your project, this is how I want you to do it. So create an input area with all the values that are given to you, and then create an output area where you have all your formulas, and refer to the input cells instead of putting in the values in the formula. And also do not pay special value. So leave that as a formula. That will allow me to see what mistake you have made, if any. So that is number of periods when you have an annuity. Next, we also looked at uneven cash flows. So again, that we can do in Excel as well, just that you have to set up for that. So here the setup is, let's say this is my year and this is my cash flow that I'm going to receive in that particular year. In this example, we have 1, 2, 3, and 4. And the value that we will receive is 200, 400, 600, and 800. And my interest rate is, I'm actually going to create an input area for that. Let's say anywhere you could do it, but let's say it's here, 0.12. So now when we are solving for present value, we could do that in two ways. So one is we could create, and sometimes we need to see the present value of each and every cash flow. So if you want to do it this way, then we will say equals present value, just like the function that we had before. So we're trying to find out the present value of each and every cash flow separately. My interest rate is 12%, which is in cell C5. My number of periods is 1 in this case, which is in B7, where my number of years are. And then my payment, I don't have any regular payment coming in the same time period, so I'm skipping that. And then my future value, the first future value that I have is $200, and I want to find out the present value of that. And remember, of course, the future value is positive, so present value is going to be negative, so that's that. Then what we can do is that we can freeze some of the cells. So my interest rate is always going to be in C5. So F4 on my computer, I don't know if it's the same on Macs, but or you can manually put $sign before C and $sign before 5. So we are freezing that. So every time we drag this formula down, the interest rate is still coming from that C5. So if you see this one, when I dragged it, it changed the number of periods to because I copied it below. So now it's taking it the number of periods from one below. So now we are discounting the second cash flow for 2 periods. And my second cash flow is 400. So it's referring to that. But my interest rate is still up there. It didn't move a column or a row below. So that is why we freezed it. And then you enter. So again, in the third one, it took it from third row, and the fourth one, it took the values from the fourth row, except for the interest rates. So that is the present value of the 4 individual cash flow. So the total present value is the sum of all the individual present values, and that is going to be 1432.93. This is how you'll do the present value of uneven cash flows. Or we have another function called net present value. So instead of having this column that we created, we can just say equals net present value. And again, you could write in 0.12 like this, or you could refer to the cell where you have the value of 0.12 where the interest rate is. And then same thing, you could write in the value. So you could say 200. So this is asking what is the value of the first cash flow, second cash flow, third cash flow, and so on. So we would just, we could do it this way, or, so let me finish it this way. So we could have said these are the 4 cash flows that we have. Cannot put extra comma. That means we have 0 in 1 year. So those are the 4 cash flows that we have. Enter, and you can see it is giving me the net present value. Or the other way was, we could have said equals net present value, start the parentheses, refer to the rate here, and refer to the values that we have already put in and in the input area. So now I don't have to write them one by one. I said my values are in C7 to C10 in the parentheses, and I will get the net present value. So of course the idea is that net present value works on the capital budgeting principle. So what you're going to receive, so the present value of what we are going to receive, that's the idea here. But here we said, okay, what's the present value? We invest something today, what are we going to get? So the idea of present value function is, if I get 200 at time period 1, how much do I need to invest today? So that's how that function is working. Whereas 1432 is saying the value that I'm going to receive in the next 4 years is equal to $1,432.93 in today's term. Okay, so those are the 2 differences that we have. That's why one is negative and one is positive, but the value is going to be the same. Then we have future value of uneven cash flows. So here we actually, I'll show that to you in the next video. So I'm going to stop.